then should be recording. Okay, hello everybody. Welcome to I think the third remote Scala Rhein Main enthusiasts meetup. And today, or maybe before that, so as always, if you have any wishes about the meetup, about the forum, maybe we should do something differently when we are remote, just let me know or talk to me in the forums on meetup.com. And if you have ideas for any talks or wishes, you can also just send me an email or mention me in the meetup site or comments. And then I can go to Alexei, who will give a talk today on how to write your own http4s middleware. So Alexei, please take it from here.
Thank you, Marcus. Yeah, so the talk today is about the http4s and how we can extend it with its own feature called middleware to bring new functionality, for example, in a nice way. So with this, I think we can start right away. So I hope you can see my screen.
Yes.
So yeah, just a few notes about me. I'm solution architect and ultra tendency, working with Scala for several years already. And yeah, also working with the big data projects, infrastructure, and Kubernetes as well. And enjoying Scala or programming in Scala. By the way, my company is also hiring. So if you want to recommend yourself as a big data developer or architect, so please reach out to me. The content of today's talk is basically overview, in short, the http4s, and then we go to its pattern that it's using from the category theory called Kleisli. We'll look at feature of the http4s called middleware, and we used it to implement one of the authentication called Spinego. It's in a note here on the slide. So if you know something about Katz effect, it's quite useful to have this knowledge, but it's kind of not required to understand the basic idea of the middleware and how this can be used. So http4s is can be described in these three points that it's also listed on its own website. That it's a typeful functional and streaming library. So we'll look at what actually this means. Before we use http4s, we have to have a few things around in the environment, like context shift and timer from Katz effect. Both things you can import from the Katz effect IO app trait that you extend from when you start when you're writing your very first class with it like a main method. Yeah, and you can parameterize it with the Katz IO effect or any other IO implementation. It's something that you need to have around. So it's a direct dependency of http4s. And in terms of type also, what does it mean in http4s? For example, we want to define some route. So here on this slide, we have a code that defines a simple route that has the server that's going to be listening for a GET request. And once user hits this request, right, will be some host name, then a slash, then a path, and this URI. There is some name, dynamic name. If this will be called, then we're going to reply with OK status with some text body, like hello and that name that was given to us. And you see straight away there is some type that is HTTP routes. And in fact, this step, if we look at the source code of the http4s, it actually type ls to HTTP of option T with F and lambda type. And what is actually HTTP is another type ls that is type ls to Kleisli with the parameters like a request to f of response. You might ask, what is Kleisli actually? So if we look at the Katz core source code, or just definition of this class, so Kleisli is a class that wraps a function that is go from type A to f of B. We will discuss further in the presentation what actually Kleisli means, but I see straight away that it's a lot of typing or type aliases in http4s. It will be quite a few things based on this model, and It's also, as we know, the types for us are basically like a documentation. So if you go straight through the types, you can see basically the idea behind particular things. Also, I think if you've never used http4s, the idea of this route is repeats in many different libraries or languages. You have something like a route, a path that's a service that is listening for specific request and calling some function or some service underneath in your application. And I think it should be familiar. And later you use this route in your server to start the server. In terms of functional, so we have this route, right? We also have a variable name for it, like a service, like hello world service, that we then plug into the our server that's going to be started and listening for user request. So in case we want to check how this response will be delivered to us, we can easily do this with just creating a request according to http4s API, given a specific HTTP method, like for example get, specify the specific URI that's going to be matching to this specific code on the top, right? That we want to go to hello URI with the Tom dynamic name, which don't really matter for this route to be hit, and then we can just run the service, the function run that is coming from clients. We can put the request and get the response back. And if we run this in REPL and evaluate the response, which is IO, instance of IO. So if you've never worked with a cats.io, maybe it makes sense to just mention that it's something like a lazy future. So it's something that will be evaluated and produce a result. So it's something like a task that gives you some result back. But that's why we need to evaluate it. In order to evaluate that, we use a method called unsafe run sync. So it's one of the methods to evaluate that. But usually we don't do this. But in terms of the running example in REPL, so we usually do this. And so if we unwrap this request and basically run that IO, this operation, we will see in the result that our request is basically was successful. It was status 200. That fits this OK DSL here on the top in the response. And if we evaluate the stream, which is the body, it should also have this hello and the Tom, right, that we've given to this route. So what it gives us that we can test our HTTP layer without starting the web server. So for me, finding this feature in http4s specifically was like an amazing feature that I've never seen before in any other web frameworks or library that providing capabilities of running web servers. That's really amazing, like that you can test that without a lot of hassle to mock some dependency or pull one more library specifically like for testing purposes to make this testable routes. Yeah, and usually because we don't have this feature in many other libraries, we usually skip the testing of this layer where we actually should check what kind of request going to be, what kind of HTTP status will be, and what the body, how this body will look like. So we often test the service layer, right? That function that will be called by HTTP layer, or maybe the system layer, but we skip the HTTP layer. Here with http4s, it's quite easy to test this HTTP layer, so you don't really need to start anything else. And in terms of streaming, http4s is also based on another library that's coming from type levels called fs2. So it's a direct dependency, and it's supporting the streaming through HTTP. If you, for example, wrap your response, which would be an instance of the stream, which is coming from fs2, and return it back to user for a specific route, then later evaluate the response, the IO of response, you will see that's going to be like some stream that the client can continuously consume. And there's also the specific header for that, which is transfer decoding chunk that makes this HTTP1 layer to act as a stream on the client side and on the service side. So specifically, this stream prints, I believe, something like 10 times the current timestamp within 100 milliseconds, something like that. So it's not really important, but that's going to be running continuously and giving back the result from the server to client. So now we're coming to Kleisli, to the pattern or Kleisli error that comes from the category theory. Maybe you already seen that in other languages like Haskell. And the name is coming actually from the Swiss mathematician Kleisli, and also can be described in terms of type tick signature. That is a function that if you give it an A, you get back some result B in context of F. So what does it mean actually, or how does it help us? Imagine we have two functions that we want to compose, like F1 and F2. And F1 returns us an F of int, so int in context of F. So it could be an IO, for example, it could be an option of int. And another function takes int and returns some another type, which would be F of double. And we want to compose these two functions. So basically, we want to produce new function out of these two using like nzem, for example, in Scala, this function that can compose function in a way that first if F1 will be called, result will be piped to F2. We want to have this final type like this. We want to give the string and get a result back as F double. There is only one problem if we compose it without any tricks. If we compose it like this, so this code is not going to be compiled because somebody has to unwrap this F of int, right, before giving the input to the F2. So Kleisli help us to solve this problem. And again, if we look at the implementation of Kleisli and the cats effect, so it's just a wrapper around function, which is called to run, coming from A to F of B. And if we look at implementation in cats, the compose method, so what it actually does is it constructs another Kleisli instance, right? So you give one Kleisli instance as input parameter, which is a k here, and it returns back to you another Kleisli, which it does something with this k. So particularly, it's running at that function on this given Kleisli, right, as an input. So k will run on the function run, and we give the input whatever it will be at the evaluation of this, or running that final Kleisli, right? This is a z here, and once the result is done, we flat map up and run and feed in the result of this running the first Kleisli that was given to us. We feed in the result to our original Kleisli, right, which is coming from here, which is this run function. So how if we look at the example, how we can use this right now. So imagine we have two functions with similar signature that we've seen before. Just a hard-coded bodies in this function for simplicity. One function is something like wants to find the cluster by namespace, right, and return maybe number of replicas. And second function is want to scale some cluster by looking at number of replicas, doing something, and return the result as a string. So in order to compose these two functions, basically to first we want to call define cluster and then scale cluster if cluster was found, right, if there was a sum. So we can use compose method on the Kleisli where we create a Kleisli out of this with the second function and compose with a Kleisli of the first function. That is how you basically get to this idea where the first defined cluster will be called, right, because of the compose logic, how it's working. Basically, we'll let first this function, and then result will be given to this function. And if we run this final function, we're gonna have a done result out of this logic, right? If we give the up one, so it's gonna return sum, and then this will be unwrapped. So int replicas will be given here, and then we go to the if true branch, where it's going to return the sum done. So that is how Kleisli can help us. And I think oftentimes people refer that the Kleisli wrapper around kind of effectful function is you can find many times mentioned in the http4s documentation that basically we want to compose effectful function that returns something like a response in shape or in form of f or context of IO.
I have a question about that.
Yes.
Can you highlight the difference between just using the option monad instance and using Kleisli here?
option monad instance?
Because you could also just do find clusters of string and then flat map scale clusters, right? Get
Yes.
the scale clusters into the result of the find clusters without unwrapping.
Yeah, but then you would need to use the flat map explicitly, right?
Yeah.
Yeah.
Yeah, so with Gleisly, we can actually abstract over the two functions and we get back a new function. With the flat map, we would just be running monads directly. That's probably the big difference here. So Gleisly just allows us to talk about effectful functions and manipulate them, and the result is a effectful function again. And with the monad, you are just running the monad and get back an effectful result.
Exactly, yes.
So Gleisly gives you some combinators to work with functions that have effects.
Exactly, yeah. If you compose that thing through the for comprehension, Gleisly arrows, like here, the result will be a Gleisly, right?
Yeah.
And in order to get the result of this final Gleisly, you need to call run. Yeah, then you will have the result, the effect.
And if somebody knows about the reader monad, then Gleisly is just an alias for the reader T. So it's a reader transformer over some effect. So sometimes, so in Haskell, for example, it's called reader T, and in cat it's called Gleisly. Just if somebody knows those terms, then it's the same.
Yeah, good point. Thanks, Marcos. So if we go to http4s middleware idea, so middleware in HTTP is something like a wrapper around your service or a proxy that will be finally calling your service. And let's look at an example. So actually, how can we construct the middleware? The middleware is something like a function that takes HTTP routes of http4s API and returns another HTTP routes, which could be upgraded or some kind of newer version with some magic inside. So what the wrapper can do actually, so this middleware at all, it basically can enrich your request or response. It can cancel the request by returning some status like full 4 or 500, depends on your logic, or run any additional side effect, right? Any chain or compose with additional side effect under the hood. And it could be a collection of metrics of your request response results. There is some out-of-the-box middleware from http4s, like authentication, basic authentication, coarse headers, GZ for compressing the body of the response, and also for collecting the metrics. I think there's one for Prometheus, and there could be something else. So middleware type in http4s, it will come back again to what is actually HTTP routes, the ls for HTTP option of T, and HTTP is the type ls for Gleisly. And if we substitute all the these parameters, so we're going to have a Gleisly that's going to be a request from option T of response. And if you remember what is option T, is a monad transformer for option, which is a wrapper for value, which is shaped like this, right? So it's an effect F that has option of A inside of F. So if we finally substitute this Gleisly, the function will be something like this, right? That means the response could be maybe optional. So you have some request, but you can return the F of none. It seems like default logic will be not found. Status code back returned to the client. In order to construct new middleware, so what we can do it, or how can do this, and where actually we can intercept the request or response. So we create a new Gleisly, right? So you remember the signature from the cats, and we have some service, some original service. We don't know actually what it does. For example, while constructing the Gleisly, we have so we construct new Gleisly where we return the function. We know there's going to be a request, and we need to return a response. So what typical middleware can do is actually run the original service by giving the request that is coming right now and returning the response. Before doing that, it can also do something with the request, right? It can add some additional parameters there, Same for response. So once response is produced by the original source, by original routes, it can enrich the response with something else, or maybe even change it completely. So that's up to your logic, up to this middleware. So depends what you actually need or what you would like to do with a request and response. There is a simple example that is also, I think, from given the http4s documentation, some middleware that adds a header to a successful response. The function that constructs this middleware takes the original routes, right? Some route that needs to be upgraded, that is called service, and some header that we actually don't know. So we construct it closely by running a request with original service. Then we map the result using the pattern matching and these particular classes and API from http4s. If it's successful, the response is OK 200. Then we add the header that was given to us for constructing this closely. Otherwise, we don't do anything, so we just return the response that it was produced by the service. So finally, we wanted to use this middleware. We call that function my middleware. We give some original or some routes that were constructed by us. We specify which header we want to add, and we start our server, usually using standard syntax from the http4s, right? So we run the builder, we bind to some port on the host, we plug in the routes with the default choice to not found. So if user hits some undefined route in our web, it's going to be returning 404. And we run the fs2 stream, right? This DSL for some compile, and we get back the IO of exit code, finally plug in this stuff to capture your app that's going to be starting our application. That's how we can do the middleware. I hope the idea is more or less clear. So I used this idea for implementing one of the applications that I needed. And this middleware is for authentication, for Spinnaker authentication. So what does it mean, this Spinnaker? So actually it's as an acronym, of course. It's a simple directed GSS API negotiation mechanism that is described in these two RFCs. The GSS is actually a generic security services API, which is in a nutshell means, or the purpose of it is something like a client is so initiate the choice of security technology and then perform the security operation. So usually it's an authentication. But this authentication and GSS API is extensively used by Microsoft ecosystem, I would say, the Internet Explorer browser for a long time, the things like Active Directory, the Windows Server. By default, the Kerberos and the GSS API is used by Active Directory as a native protocol. Yeah, it's also so one of the security authentication protocol. So I must say that it's a Kerberos. And this Spinnaker particular authentication is also supported by Chrome and Firefox. In Firefox, if you go to address bar and type about :config, you will find some properties that are configuration in your browser that you can specify actually when to use this particular application, Spinnaker, for which domains, for which realms. So in an Active Directory or Kerberos, you have this idea of the realms, right? Your kind of domain name or like namespace where all our users are registered. And you may say that, okay, for this realm, if I ever log into some website that belongs to this realm, I wanna use my credential that I already have on my Windows machine. Or if it's a Linux, you can also use Kerberos client that's authenticate itself using the tickets. And whereas in Linux, you, for example, can find this kirby5.conf on your machine. It's also in the same location at OSX, sorry, where there's some mapping between the realm and the server that actually will be used for Kerberos to find the KDC, the Kerberos distribution center, or even the key distribution center, sorry. So a bit of visual diagram of the idea of this Spinnaker authentication. So it consists of 3 parties at minimum. the client application, the server application, and the KDC, Kerberos KDC. Probably also worth to mention the idea of the Spinnaker authentication is when you're using some enterprise application in a company and the network, and you don't want to, or administrators do not want user to explicitly log into this application using maybe some login form. The administrator who wants to people automatically log into some corporate websites by identifying the login by user credential, which are already taken by when you log into your machine. So typical situation could be people are working in a big company where they use Windows all around, right? And when they log into their machine, there is a specific Kerberos thing that is created on your machine, which is something like a Kerberos ticket. That's the thing that is already there on your machine is created once you log into your Windows machine. And then if you go to some corporate website of your company, it will open the page without the login, just because you already log into your workstation. So that's the idea. And even if you go to that website, you'll see also maybe on the right corner of the web page your name, because it's already kind of derived from your operating system that you already log into your machine. So that's the kind of the main idea why this authentication is needed, or why organization enterprises would want such kind of authentication. And eventually one of your server can be also part of this network, and you want to make an application that will allow user also to open the page without asking them to log in. That's where this Spinnaker comes and helps. So now I'm coming back to this picture, how the whole application is working. So we have a client application where there is something like operating system layer, and on the operating system we have internet browser. So user logins to their machine, they automatically get this Kerberos ticket that then they usually don't create manually in Windows. In Linux or OS X, you can create this ticket by running some commands or maybe some graphical clients to authenticate against the Active Directory or Kerberos. So once this ticket on your machine exists, so ticket is something like a session, a session token that exists on your machine that needs to be validated or refreshed at some particular time. So it has some expiration date. Then in advance, user configures they configure their browser to trust specific websites. To then browser is able to take that ticket and implicitly create another ticket and send to server. So server recognize, okay, this user coming actually from our network. It's already logged into the machine, so I can just open the page without even asking the login. And also in internet browser, as I shown you on the Firefox example, you configure that by putting the trusted URI. Trusted URI can be just configured with a host name, so you don't necessarily need to put the path to a specific endpoint or page. It can also be configured with just a realm. But let's say we configure that trusted URIs by putting the website in its host name. User opens this in their own web browser, and what's going on is there's going to be a GET request to the server, and server, if it's implementing this Spinnaker authentication, it's returning back some header. So header is actually well known as so it's a specified header which needs to be used by Spinnaker protocol as a 3W authenticate, which has a value negotiate space the server token. Basically, the idea of this here, it's sending a challenge to a user, so that user has to reply with the answer to this challenge. And user replies automatically by sending another request to the server by including the header, which this time is authorization header with the value negotiate space the client token. And this token is used by server to establish so-called Kerberos context. And if it's established, then server automatically trusts the user and can open the secured resources. And usually server can also send something like cookie headers back with some expiration time. The cookie can be actually a GW token with some encrypted data that is used then by server back when user hits the same endpoint and any other endpoint on this website. It's also worth to mention that the request that are sent by client second time, right? This one, the step number 6, is done automatically by the browser. So user don't need to send or do this manipulation by including this token. So browser is doing that. If it supports Spinnaker authentication, as I shown before on previous slide, you have to have a configuration, and then it will be sent automatically. So
how does the browser know that he has to do that? Or is it doing that for any URL, or just if it sends back the header?
It knows it by this configuration. So
okay.
in advance here, you go to your browser. If it's if it's
okay.
not like a Windows thing. So I use this stuff, for example, on OS X and on Ubuntu. You're going to configure that like this. Usually in enterprise.
So for everything that goes to example.com, it knows about Spinnaker.
That's a name of this realm. It's just a name, any fake name for this particular example. But if we compare that with specific this example, like some trusted URI, you can put exactly this URI there. So it's going to be like HTTP, some trusted URI. So it's just a mapping for a browser or a value or a flag that knows, okay, if user ever hits this website, then I need to use this Spinnaker authentication, and then go and find that ticket on the user machine while replying back to the server on the challenge. And yeah, I'll just maybe repeat again. So here it's you can put either realm like this, and then in this conf file you have a mapping from the realm to the website, and that means you can either hit the in browser this example.com, and it will find that, okay, this is the realm that has a KDC on this port. So it boils down to the KDC address where the browser will start to communicate with while creating this ticket or validating the request. But this can be configured. As I know, on Windows, you don't really need to do that if it's already like managed workstation in a company. They already have this mapping or the trusted URIs already configured for them in the browsers, like Internet Explorer or whatever the browser they use. Yeah, so it's browser will know if there is some website that expects Spinnaker, that expect client to send this challenge, but it's not configured on the client side, so nothing will happen. Server will send this challenge header with a status 401, and user will see a response on like unauthorized, and that's it. So if browser is not configured, nothing will happen after that. That's kind of the difference. This negotiation protocol, Spinnaker, is also supported by curl. There's an option for that. Curl is also will send the second request automatically once the response from server is this 3W authentication that asking the client to perform a challenge kind of request. So it will do this as well. And yeah, so let's go and see how we can implement that with http4s. Let's imagine that we design our Spinnaker middleware as something like a library, like a class that's going to be using some configuration, CFG, and construct a couple of things inside to finally give a user this apply method that it will give some routes from the user and will return the routes back. Inside, we also have some Spinnaker authenticator, which some value is going to be used by us inside internally. And we have two things here, like auth token and on failure. These two things or implementation of variables of such types are required by http4s to implement some middleware. So these types like auth middleware and auth routes are coming from the http4s itself. So that's http4s API. But we're going to construct our new middleware on top of http4s, obviously. So what we're going to be doing, we construct the auth middleware. It's a little bit different type that middleware that it has as well, but we will look on the type signature in a second, what they mean in HTTP4s. So user is gonna call the apply method on this Pinego class. Is gonna first instantiate it with a new, for example, right, keyword, and then and it can call this apply method to give us a service that they want to wrap with our middleware that under the hood will do this, sending the challenge header and checking the challenge header from a reply from the client. So the first thing, it was to mention, auth middleware takes these two values. One of them is like the main flow auth token, which is a type of closely from request to response, where we have the response. Well, it's not really a response. It's something like intermediate result, where we have a request as an input parameter, and we have a result either, which means two things, right? Either it's error, so not successful, or something that user needs back in the either as a reply, or maybe your server needs back. So this is going to be our code, our custom class, which is called auth token. So that's going to be a closely. We construct it like this. So we gave we only interested here in the headers of request. That's why we call some authenticator that we're gonna look later. What does it mean in the code? We only pass the headers. And second thing is on failure flow. It's something you can plug in your code in case there is a rejection, right? If in case this either happened on the main flow, you can also reply with some specific response. And this auth on failure is another value that you need to implement with the auth middleware. And from user perspective, so if we implement our new server and we want to use this middleware, so what we do is we construct our routes, which this time is not just HTTP routes, but authored routes. Authored routes adds additional context to your routes, and then give you something like a variables that you can take of this context. So we parameterize the auth routes with the auth token, which is our class that is we define around, and it's going to be a route that you write, and this body or this response will be only returned back if the authentication succeeded. So even you see there's an example that this page is protected using this piece Pinego. That means if user ever seen this response, that's the authentication is already performed. So this body will not be called until the user is authenticated. So in order to use these routes, what you do, you create a new instance of this Pinego class that we've seen before. You give some configuration. Let's imagine there is some server principals and other configuration required for this Pinego authentication or Kerberos authentication under the hood. And we plug in this auth routes. And as you remember, that apply function that we have right here, it returns back as normal routes, HTTP routes. So we have them back here. And then once we have the routes, we can plug in them into our server and start the server. So there's already a final point where we can use this middleware. So now let's look at the types of the routes and of the request. So you've seen what is HTTP routes, and auth routes is an API coming from the HTTP4s as well, which is a closely, this time not just a request, but authored request. The rest of the things are the same, so the option T response. And authored request is a type alias for context request, and a context request is finally a case class, which is a wraparound request with some context of A, right? It's a generic type that you can plug in your specific context that will be provided to you, available to you when you're going to be already in your routes. So this is actually this type of token that we define for us, which could be anything actually, right? So for this Pinego authentication, we have something like a notion of a principal. So we call things in Kerberos authentication or Active Directory users, we call users as a principal. So we also use this notation here, and some other premise like expiration date, maybe that way. So eventually this auth token will be serialized into the cookie and maybe encrypted, right, and return back to user as JWT token.
Wait, that's a lot of type aliases. Can we try to unpack that? So what in the end is, what was our auth routes in the slide before that?
Our authored routes, you mean on the slide?
So we have an authored routes of auth token and F, right? So it's generic over the effect.
Yes.
And if you now go back to the next slide, so the first parameter is auth token. So in the end, we have a function from an auth request, which is a context request of an effect and our auth token. That's the argument to our function, and the result is an option T over a generic effect F that returns a response.
Yeah, maybe it will be a little bit clear on the next slide. It's given a bit more type aliases, but, but there is some particular idea in this aliases. So let's look what is actually auth middleware, right? So auth middleware is a type alias for a middleware where it has a lot of type parameters. So and then we need to immediately look what actually is middleware. It's a type alias finally for Kleisli to Kleisli. So this is like a function in, function out. So middleware, as you remember how we construct it, we take some routes and we return some routes back. And HTTP routes is a Kleisli, right? So that's the idea of middleware. So you give some Kleisli as in, and we return some new Kleisli, which something will be upgraded with those business logic of the middleware. So if we substitute this stuff finally, so this is how it will look like. Maybe it will answer your question, or maybe it will be clear. So the first Kleisli is is coming from authored request to option T of response, and the second Kleisli, which is returned back, if you give this kind of Kleisli to it, it will return a normal Kleisli with a request to the option T of response. So that means that user, if it creates their own middleware, have to define routes with this authored request type, and it will have the additional context in the user's routes. But then we wrap our routes with the middleware, we get back the normal HTTP routes, which we can plug in finally to the HTTP server, to that Blaze builder, or to the server before we started. So that's the idea. So the auth request or auth middleware just provide additional context to the user routes to basically capture that information about the user, like the username or whatever the thing that will be created out of successful authentication of the first Kleisli. Is it a little bit more clear right now, or worse?
I think it's only clear once you have used HTTPS for quite some time, but so it's a lot of type aliases. I know that when I tell other people about that, they are normally like, yes, let's just inline all of the aliases.
Yeah. For you, I specifically made this on the slide, this substitution. So on this slide, right, we see that it's a Kleisli to another Kleisli. And if you know what Kleisli is,
does everybody know what the Kleisli does from the first slide? So I think it would be helpful here if we could just unpack what it actually is. So like the Kleisli is only the function that takes the auth request, which is a type aliases, which is just something else, which is something else again.
Yeah.
Do we have the ability to type this in the IntelliJ? No, or yes, I don't know. Do we have the project open?
Yes.
Maybe we can try if the other guys are interested.
I have not IntelliJ, but we can also go to it if you want. It's already wrapped, so it's already project with this code.
Mm-hmm. Can we just type the one from the slide, the upper thing?
We can try.
And then just inline everything and just rewrite.
You mean one of these types?
Yes. So we have the Spinnaker. Can you in the code go to the Spinnaker auth middleware?
Like
in IntelliJ, maybe?
Like this one?
Maybe in IntelliJ? I don't know if that helps.
Yeah, sure.
So somewhere there is the middleware, the auth middleware.
Yeah, so we have here authored routes. The problem is that the code here is a little bit different, but it's quite close to the slides.
Yeah, so in line 56, we have auth middleware. Can we copy the auth middleware f and auth token just to maybe some empty file or some, maybe just at the bottom, I don't know.
Yeah, we can do this.
Just the type of auth middleware f auth token.
I mean, like this?
No, just type it. It's not valid Scala, but we will just type an inline because I think then it will be clearer what we're actually doing.
Okay.
Just the type. So in line 56 at the end, after the colon. Yeah, just the type from between the colon and the equals.
I'm not sure what you mean by type.
Just the auth middleware of f and auth token, the result type.
The return type, yeah.
Yeah, the return type is here, right?
Yeah, can you copy that?
Okay.
And put it on a separate line. So now if you jump into auth middleware, we can see what auth middleware is.
Yeah.
That's not the type. Where's the type? Can you scroll a bit down?
No.
There.
Yeah, this one.
Yeah. Can you copy line 77?
So you wanna unwrap these types, right?
Yes.
Oh.
Yes. Just so that everybody can see what it's actually doing.
Yeah. So actually, it's already unwrapped on the slide, so I'm not sure if you.
Yeah, but not to the very bottom. There are some steps missing.
Okay.
Okay, so now we can fix the T to auth token in the second line.
So it's like
maybe just put it on a separate line. Maybe it's easier if it's top to bottom because there will be more lines.
Okay.
So if you in line 68, if you replace the T with auth token.
Yes.
I think you can just do it in line 68 because the generic T is already missing. Yeah. Okay, so now we can maybe first unwrap auth request.
Yeah, so it's going to be context request.
In a separate line, maybe. So it's step by step. And then I think the next line, so context request was just the case class that basically wraps a request and the auth token, right?
Yeah.
Okay, so we know what that is. And if you now unwrap the middleware so that you have Kleislis on the next line.
Let's see if we can just copy it.
Yeah, you should just be able to jump in there.
No. So this is the middleware type, right?
Yeah, now you have to replace the F with option T, F star. And the A with context request, F auth token, yeah. Yeah, and then we have response and requests.
So the response will be
and D as well, right? And C is request.
Yeah.
And then next step, just unwrap the Kleislis because I think then it's pretty clear what it's actually doing. So now we have a function that goes from context request F auth token.
Yeah. So that's the parameter of the first function.
Of T of F and response F instead of star. And now you probably want to put parentheses around that. And now the function arrow, and the result is a new function.
Yeah, so result, but this time it's going to be just a request.
Exactly.
and go like this.
Yeah.
Yeah.
So we get as an input, we get a function that has a request with some context, and it returns a normal response. And what our middleware does, it does something with the context to give you back a normal function that http4s normally has for routes.
Yeah, which http4s understands how to plug in into server and basically use after that.
Yeah.
Yeah. Yeah, hopefully it's a little bit clear right now. It's indeed, I agree with Marcus that these types will start make sense once you be using some of the middleware or the existing one, or maybe you're creating your own middleware. Okay, then let's continue. Just want to comment this. Yeah, so in this slide, what we've done compared to what we've done in the code, we would also need to substitute this star with auth token, and this will be quite close to what we've done, but then yeah, we can unwrap the closely as well here. So let's move to the implementation of the actual Spinnaker flow. So there is some Spinnaker authenticator, right, that has some entry point that we called apply that takes the headers. So it will work on the level of headers because you've seen that the Spinnaker is actually only interested in the HTTP headers. And the result of this authenticator will be f of either. So the result will be either successful, if it's successful with auth token, with the principal name and expiration of the session, or rejection. And rejection is some ADT, so some enum that has specific reasons for a rejection. Like there is some wrong header sent by user, or user is not allowed to authenticate, or there is some bug on the server, it's like a final error. And this flow actually can be composed using three functions, like a cookie token, care-based negotiation, initiate, or initiate negotiation. So what they actually mean. You remember that the first time when user opens the website, the server usually sends a challenge back to user that user needs to reply with. And for that, we're gonna use the third function. So maybe let's look also at the type signature of these three functions. So the first one in the flow is actually a cookie token. So what does it do? It takes the headers and it replies back with optional either. And either is actually either rejection, so there's something wrong with the header, or cookie is already present. That means user sends the same auth request second time for some reason. So we just return the cookie back, and we derive from the cookie this auth token type, and we will give it back to the routes that user of middleware is using right now. So that means the cookie found, so we do nothing and return it back. But if there is a not found, cookie is not found, we go to the second function, right, which is composed with this f of option of either through or else, right? So we call the care-based negotiate function that takes that again works on the level of headers. And what does it mean? Basically, if there is no cookie but client token is found, that means this could be that second request that user sends to us automatically. So we try to authenticate user against Kerberos. And type signature is very similar. So we either successfully authenticated or we return back the auth token with the successful result of this authentication. So if there is no authentication happened, so if it is the first time, as I mentioned before, the final function which will be called is initiate negotiations, which is just returning the challenge header to the user. So basically, the very first time we're gonna fall into this function, and then if user replies back with the challenge, we fall into this function, right? We kind of go from bottom to top. And once the user will be successfully authenticated, and we'll be sending the same request again by some reason, right? We're gonna return this token. Actually, this function will be used every time for all other routes if our routes are protected by middleware, by authentication middleware, because we always need to check that this token, that cookie still exists, right, before working further. So that's basically the very first function, which will be called afterward the authentication succeeds. And from the onFailure function that we need also to provide that auth middleware idea, we already know that this function, this flow, is already failed. So we just need to provide correct response based on some rejection reason. So rejection is some custom code that we will write, is an ADT that has a couple of reasons for rejection. So one of them is authentication failed rejection. There also could be a malformed header, or any like a final or fallback error, server error rejection, that basically there is some bug in the server code, or there is some network problem with the downstream services that this http service is using. And we return back either the response, where in the response we basically say that you are not unauthorized right now, and we return back some message, right? But we have some custom rejection ADT, but we don't expose it to user. We return some string message back. And in order to implement this, actually the final kind of implementation of Spinago, to work with the Kerberos and do this properly with Active Directory, we can use Java API, which provides, since version of 1.4 from the very long time release of 2002, API for working with the Kerberos and in order to implement the Spinago authentication. There are some classes to work with that, so mostly coming from the security package. And yeah, this API is enough to make this authentication working by only using classes from the JRE. Of course, there are always a pitfall if you use either Java libraries in your Scala code, or just libraries from the standard Java distribution. For example, in these classes, in this API, every method can throw an exception. Constructors also throw in exceptions. If you use this API, they may return null as a valid result, or they takes null as a valid parameter. So what we can do, or what we usually do when we deal from Scala and we use some Java library, so we will wrap with some nice facade from Scala perspective, right? And then everything gets fine. So we actually then don't need really use to other libraries that kind of provide the service to us. Already implement this Kerberos authentication. They are also using this API, actually, if you found something like that. So, however, this authentication is not that hard to implement yourself, just writing your code and using the standard API from Java. There are many examples actually from the Oracle website on the Java documentation, and also I made some time ago some article on how to generate user token if your client is actually another Java application, with some article on this link. In final implementation of this function that makes that authentication, one of the functions that in the flow, right, that we've seen for our token flow, the auth middleware, is going to be doing something like this. So this is the Scala code, but it's using those Java classes, Java API. That particularly we do on the server side while we're starting our server. So our server also needs to be authenticated against the realm, against the Active Directory, right, using the Kerberos protocol. And using this Java API, so what we do, we construct some so-called login context by using server principal name, right? While constructing this subject, we give the subject to a login context. And when we start our server, we'll log in our server to Active Directory. That means our server is kind of going to be trusted entity within this flow. When finally the client is going to be calling the server, it's a server that actually authenticate against the Active Directory. So not just a entity that is just a middleman or untrusted. So basically, this is how we do our server to be trusted. We'll also construct here a GSS manager, which is going to be used on the second slide for the authentication during the runtime, authentication of the user. Right, so for authenticating the user, we run this privileged action using the standard Java API, where inside of the run method of this privileged action, or exception action, so what we do, we use that previously constructed JSS context, and we feed into it the client token that will be sent to us based on the challenge that we send from server. So client responding to us with some token. And this token here, it will be passed to this JSS context that we created before on the startup. And if established context returns as true, that means that the token is valid. So we can trust this user and unlock the protected resources. Or basically, yeah, we return the auth token, create a cookie, and then we're going to trust to this user based on the cookie and based on the session. And that's basically it, how you can implement this Spinnaker authentication using just Java API and http4s. So this particular code I also wrapped into a library. It's available on GitHub. You can use it if you ever need to do the Spinnaker authentication, and if you're also using http4s. There is some project that this library was inspired from. There is also a similar project that I started from exists for akka-http. And in summary, what I want to say that first of all, http4s is really easy to extend with your new middleware quite easily, especially if you plan to reuse this middleware maybe in another project. That is nice to pack it at the maybe library, internal library, and use it everywhere. And second point, that actually you can implement the Spinnaker authentication, particular authentication using just Java. So as turned out, Java has quite a lot of things that we maybe not need every day, but it sits somewhere in those old APIs, and you find this, yeah, it's kind of surprised it also has that implementation that you don't need to fall back to another language maybe, or yeah, something like that. So that's it from my side. If you want to contact me, so please use one of the links here. And if you have any questions, so please ask them right now.
Thanks, Alexei.
Yeah, you're welcome.
Is there any way to compose middleware? So can you, so I guess it's easily possible to just compose different middlewares.
Yes, it is.
There is functions, yeah.
I think I have maybe even an example. So you can, for example, oftentimes today we write web servers together with the client, where client is SPA, right? And it's calling server from across domains. We need this support of course headers. So course headers is out-of-the-box middleware from http4s. And what I've done actually, yeah, you can wrap routes with many middleware as you need, right? And as we remember, this is just a wrapping of function like this Kleisli. So we can, for example, wrap our routes with the Spinnaker authentication, and on top we can wrap them with course middleware, and on top we can wrap with any else. So it's like going to be giant ball wrapped with many layers. But eventually you'll get back the normal HTTP routes variable that you plug into the server, and that's it. So you have this then chain of the connected middleware. Now let me maybe just try to switch my light here. Just a second.
Yeah, it's a bit dark. I think I cut off Frank, who wanted to say something as well.
Yeah.
No?
No? Okay. There was one other question by Gregor in the chat, if you can compare http4s with http4k. And I guess http4k is for Kotlin. I don't know.
Yeah,
To be honest.
It is. But maybe expand a bit, because I think there's kind of similar, because http4k is also around this server as a function paradigm, and I think http4s does follow it too, right? So I wonder if you ever tried http4k, and yeah.
Yeah, I've never used http4k, so that will be interesting to see. Yeah, seems like it's a Kotlin library.
Yeah, they referred to a paper published, I think, by Twitter, and they say,
The
and
server
that
is a
is very,
function.
yeah, right. And I remember that http4s also was one of the first implementations, actually taking this idea into the real world, if I'm not mistaken. So I don't work with it. So
Okay, that paper seems interesting.
Yeah, I've heard many times
I've already
reference
heard
to
of
this.
that. Yeah.
But never read that, probably.
Maybe I should.
Yeah, I just wanted to say that.
yeah. So
yeah.
Okay.
Interesting.
But if you didn't use it, then my question doesn't make any sense. So it's okay.
But have you used http4k?
Only in a toy project.
Okay.
But yeah, but it's similar. So like you also so for the model itself, it's a request. So they say the request to response. You have two types of function: request to response and request to request. And request to request is like a filter, and then you can compose them. And that's the idea behind that. And
But
in
I
the
guess
end, you can.
does Kotlin or http4k have any notion of effects in the function of the request to response, or is it just request to response?
I think it's just request and response, but yeah.
Then I would say that the Scala version is more abstract, because in the Scala version you abstract over your actual effect type, and you can do a lot of stuff with alone this fact.
Yeah, for sure.
But it seems interesting. I need to take a closer look, I guess.
Yeah.
Okay, then thanks.
Sure. Any other questions?
I have a deeper one, but maybe somebody else first.
Maybe I actually forgot. If you want, I can show you how does it look like from curl perspective. I'm running the web server at right now at the Kubernetes cluster, which is using this middleware as a library that I published on GitHub. And I'm also have, maybe let me just make it a little bit bigger. So there's a Kubernetes cluster, which in the test namespace has a couple of pods. One of the pod is http4s server with its library. Another pod is the client that is just a pod which has a curl inside. And both these pods, they have a connection to Kerberos, which is also running in Kubernetes. So wrap it as a container, obviously. Both client and server have a key tabs, actually this notion of kind of secret that allows both parties to, first of all, authenticate against the server, against the Kerberos, our Active Directory, if it is. And how does it look like? So if we go to client pod and run this flow request, so I have some script there. So if we go to shell of the client and make this bigger like this, and I have a script. What's going on? The test script inside the test container, as you can see, I just log in through the key tab. The key tab, if you're not familiar in the Kerberos, it's something like a saved password into a file in a binary form. You use it to log in yourself, particularly your machine, to against the Kerberos. And then it's calling this curl command with the negotiate option. And on the server side, server is already started with also login to the Kerberos. And if we run the script, so it's going to call this endpoint, which is test server, which is a Kerberos Kubernetes service, without any like a slash or endpoint. So just, well, it is endpoint. There's auth endpoint here. The final name of this server is server name, or endpoint is /auth. So if we're gonna run it, let me show you what happened. So from client perspective, this log, a curl verbose log, right? So we call the server, and the response out of the server was the first time unauthorized, as you can see, right? This is the response from the server. What then curl actually is doing under the hood, so you don't really run manually the second request. The curl is doing it automatically. It's run the second request here, which is again get auth, the same endpoint that you ask curl to do initially, but this time curl automatically includes this header, right? The authorization with this token that was taken from the operating system, from the token, from the TCAP that is created by Kerberos authentication. And finally, the server returned OK to this protected page of this HTML resource with OK status, and there's some message that was like this, that this page is protected by HTTP spinning authentication. So that was the response from the server. And what happened on the server side is, since I already ran this before the presentation, so now it's a bit harder to show you the initial flow, but I think it's still possible. Yeah. So we got this request from the server, from the client. Let me make it bigger. So same flow, but from the server perspective. This was the request. We return back to the user the response saying that it's for one unauthorized, then this challenge header. We also put into the body a message like credentials are missing. So if it's will be shown on the web page, at least the user will have some error back or like some message. But usually it's for tools, right? It's for a browser that's doing this automatically, or for curl, or for another application. Then clients send the second request, which is here. So we see that's what clients send to us, request headers. And then we send second response to the client. This is how it's working under the hood. Yeah, that's it that I wanted to show you how actually it's implemented.
Cool. Any other questions? Okay, I think let's wrap this up. So thank you, Alexei, for your talk.
Yeah, thank you guys for joining.
Yeah, exactly. Thank you everybody else for joining. Hope to see you next time. And I will leave open the Zoom room, but I will just stop recording now. So hope to see you next time.